Things that bother you never bother me. I feel happy and fine. Ha-ha! Living in the sunlight, loving in the moonlight, having a wonderful time. Having got a lot, I don't need a lot. Coffee's only a dime. Living in the
Oh no! If you ever want to see Bowen and Alexander again, you have to learn basic integration techniques and use substitution by... Wait, what day is it today?
Monday.
Wednesday.
Well, what's integration? My poor puppies. Hello? Hello, Nil? Hi. Do you know integration? You don't? Okay. You said check a calculus book? Oh, I think I have one lying around. Okay, thanks. Bye. Ooh, a calculus book. Oh my god, what is calculus? Who could that be?
I heard the calling for the mathematical messiah.
Mom, I told you to lock the back door.
I'm not kidding, just watch this.
No, where did that come from? And what are you wearing?
Don't worry about it, it's vintage. Take a seat. I hear the calculus mugger is giving you some problems. You need to learn integration.
Yes, that's true.
Do you have any clue what integration is?
If I did, do you think you would be here?
Don't get smart. Could you tell me what this means to you?
It looks like a giant S.
No. Try again.
Let me see this. Is it a snake?
Sit back down. I shouldn't even gone that far. Let's start at the very basics. Given the function f of x equals x squared, find me the first derivative, f prime of x.
Why, it would be 2x, of course.
Perfect. Can you find me second derivative?
It would be 2.
Perfect. That's basic derivatives.
Yes.
What integration is the exact opposite. When you're given an integral, which is what this is an integral,
Oh.
not a snake,
Or an S.
and a function inside of it. Actually, let's start more basic than that. You do the exact opposite of what you did to get from here to here. Now, with 2 inside of your integral, you're going from your second derivative right here up to your first derivative. Thus, you are taking the antiderivative of it. So, the integral of 2 is going to yield 2x.
Seems simple.
Alright. Let's start with the integral of 2x in that case. To get from 2x to your function of f of x, it's going to give you x squared. Because you are doing the exact opposite of what you did here. Here you drop down your exponent. Instead, you raise it.
I see.
This could be shown.
Is that a sock you're using to erase?
Yeah, I just got back from Baby Joe's locker. This can be shown through the integral of x to the n x to the n plus 1 over n plus 1 plus c. Now I know the c is going to confuse you. I'll explain that in a second. The formal equation for an integral is x to the power of n will equal x plus that power plus 1 over that same n plus 1 plus c, which we will get to. Let's revert back to our original function, f of x equals x squared. When you take the derivative of x squared, you drop down your exponent and subtract it by 1. So you get 2x to the 2 minus 1 is going to be to the first. Now, inversely, when you have 2x in your integral, you have a 2 plus the x 1 to the first plus 1 over 1 plus 1, because your n is 1 and you have to add 1 to that, plus c. So that's going to equal 2x, so 1 plus 1 is going to be squared. It's going to be over 2 plus c. Thus, the 2's cancel out, leaving you with a final answer of x squared plus c. Now, as you can see, that's why the 2 is now gone.
I see.
Good, good. Now, I know you're probably really confused on more than a couple things, such as the dx, where that comes from, and the c. When you're given a function, y equals 2x, let's just do y equals 2x. Take the derivative of that. It's going to give you dy equals 2dx, because the derivative of x is dx. You divide this by dx, crosses out, so dy dx will equal 2. The dx essentially tells you that you are integrating with respect to x, as you can see by this. Do you understand that?
Yes. What just happened? Where'd everything go?
I am divine.
So what exactly is that plus c for?
I'm getting to it. Relax, youngster. Let's give you the function f(x) equals 2x plus 1. What does f prime equal?
Let's see. Well, it's simple. 2.
Okay. Alright, let's go to the next function. F of x equals 2x minus 7. What does f prime equal?
Another easy one. 2.
Do you see our problem here?
No?
If we were to integrate, actually let's integrate it. If we were to integrate 2 dx, what would that equal?
2x?
Now, as you saw before, we had 2 functions. F of x equals 2x minus 1, and f of x equals 2x minus 7. Both have the derivative that's equal to 2. For this reason is why we have to throw in the plus c. The plus c is going to account for any coefficient that will not show up when you integrate.
Makes sense.
That it does. Let's move on to a practice problem. The integral x squared. Actually, let's do something more fun. 4x squared dx. Integrate that for me, please.
Would it be x squared plus 1 over 2 plus 1 plus c? And you could simplify that. But what do you do with that 4?
Well, before we go on, let's ask fact checker Pav first, if that's even the correct answer. Fact checker Pav?
Wrong.
Alright, as you can see, fact checker Pav told you that this is wrong. That 4 can be brought outside of the integral because it's a coefficient of x squared. So this is essentially 4 times the integral of x squared dx, in which then you have the correct answer, x cubed, well, but you have to do it times 4. So it'll be 4 times x squared plus 1 over 2 plus 1 plus c, giving you a final answer of 4x cubed over 3 plus c. Any coefficient that is in front of a number, or in front of a variable, can be brought outside when it's simple multiplication like that.
Okay.
Alright. Let's give you another problem that I think you'll be able to get. Integral of x to the 5th dx. 6x to the 5th dx. Please show me how to do this.
Let's see. I think I'm starting to get the hang of this. Would be 6 times the integral. Those 6's divide out, and you'll be left with x to the 6 plus c. How'd I do?
Let's ask fact checker Pav.
You are correct.
As you can see, you got the correct answer.
Does that ever get old?
Nope. Let's go more tricky. The integral x cubed plus 4x dx. Could you tell me what to do here?
I don't even know where to begin.
I'll show you. The plus sign is essentially adding the integral of x cubed plus the integral of 4x dx. Now that we have it split up into two separate integrals, it becomes much easier to integrate. The integral of x cubed equals what?
X to the 4th over 4.
Good. What does the integral of 4x equal?
4x squared over 2.
So 2x
You
squared.
simplify.
Now that you have your two answers, it's as easy as adding them together. And of course, you can't forget your plus c. Had the x cubed and the 4x been multiplied, you would not be able to do this. But because it was an addition, or subtraction for that case, it separates your terms, making it so you can separate the integrals, as you can see right here. Add them back together, and you have your answer.
I think I'm starting to get the hang of this.
Good. Let's move on to some trickier stuff. F of x equals sine x. If f of x equals sine x, what will f prime of x equal?
Cosine x.
Very good. Now let's give you cosine x dx and your integral. Now remember, you're taking the antiderivative of cosine x. What is the antiderivative of cosine x?
It would be sine x.
Good. As you can
Plus
see,
c.
f prime goes back to f of x. So this will be sine x plus c. Now we have tons more trig functions. Let's move on to our more obscure trig functions, such as secant, cosecant, tangent, and the ones that we see less often. A simple trick to remember this is psst, where the P doesn't really stand for anything, but the S and the T stand for secant x and tangent x. This is extremely helpful for integrating these functions. If I were to integrate secant squared x, it would give me tangent, because secant times secant will give you tangent.
That makes it so much easier.
Okay, next one. What if I did tangent x times secant x? We have our tangent and our secant, thus we are only left with our secant, so it is secant x
I think you're forgetting something.
plus c. Very good. Very
Other
good.
than that.
My dx.
Mm-hmm.
Never forget that dx.
Yeah, God forbid.
Don't talk about my father that way.
You forgot it somewhere else too.
Very good. Very good. Just call me out on everything.
Don't worry, I won't hold back.
Alright, now that we know our secant and tangent, and psst, everybody's got to remember psst, secant x, and tangent x.
Don't worry, I'll never forget it.
We're going to move on to our other of cosecant and cotangent. For this, we can use which stands for cosecant x, and cotangent x. So, having just done the last one, I want you to integrate cosecant squared x dx. You want to write it? Okay, you can
I'll
write
write
it.
it for you. Since you seem to make too many mistakes. Let's see. Equal to cotangent x plus c.
Perfect. Since we have both secants used, you're only left with the cotangent as your answer. Let's move on to cosecant x times cotangent x dx. What would this equal?
Cosecant
Very good.
x.
I know what you mean. I am mathematical messiah.
Of course you are.
Those are our special rules for integrating trig. You're always going to need to know them because there will be a lot of trig integrals in your future. Believe me, I know the future.
Is that just one of your almighty powers?
I'm divine. Now, other than trig, there are a few functions we're going to have to know. I already gave you the function f of x equals e to the x. What would f prime of x equal?
E to the x.
Very good. I see you've been studying your derivatives.
Oh, I have.
So, if I were to give you the integral of e to the x, what is your antiderivative?
E to the x.
And we have to add on
A
our
c.
c for our constant. And,
You forgot your dx again.
oh my god, you're right. Very good.
Thank you.
I see you're catching on quick. Calculus muggle is never going to be ready for you. Alright. Let's do... Actually, I could have left that up there. But the integral 1 over x dx. Do you have any clue what derivative of what function will give you 1 over x?
Is it natural log of x?
Perfect. The derivative of natural log of x is equal to 1 over x. For this reason, the integral of 1 over x dx will give you natural log of x plus c. Isn't there just so many fun parts to integrating?
I just love them all.
One last thing I want to show you, even though it doesn't come up very often, would be the integral of any constant. In this case, we're going to use the term a, to the x dx. Now, I know you have no clue how to do this, so I'm not even going to ask you. The integral of a to the x dx will give you that same a to the x over the natural log of that a plus c. These are just another thing to remember for integrating. Although this does not come up often, you may have to know it. I think we're ready to give you one last practice problem for today. I'll give you a little tricky one. The integral of 4 over x plus 3x cubed plus cosine x dx. Please evaluate this integral for me.
I got this. Let's see. Bring that 4 outside. That's a D, not a heart.
Very poor D.
That's ln of x, so how'd I do?
Let's ask fact checker Pav.
You are correct.
As you can see, fact checker Pav thinks this is excellent. It shows that you learned all of my cumulative ideas, and I think we're done for the day. With this kind of integration, you'll get your dogs back in a second.
Good.
I'm going back to mathematical heaven. You can go to sleep now, because I know you're tired from all this integration.
I'm exhausted. Oof.
And I know that the calculus mugger told you you have to learn U substitution. So, I'll be back for one more day.
Oh man, I hate when he does that. No. Whoa, when did you get here?
I knew you woke up. Time for your new lesson. Didn't sleep well, did you?
Not at all. I had bad dreams.
Believe me, I know. Today, you're going to learn U substitution. Since we learned our basic integration yesterday, let me give you a problem. Please try to solve this for me.
I don't know where to begin. Would you use chain rule?
You cannot use anti-chain rule on a composite function like this. The same rules do not apply in this case. When we have a composite function, we have to revert to u substitution. If I were to give you the same integral with only one term, we'd be able to integrate this as what's supposed to happen? Correct?
No.
No, it's not, is it? No, it's
Correct.
correct. Thank you. So, let's go and try to make this x minus 1 into a single variable, such as we just did, so we can get an answer like we just did. To do this, we are going to substitute our x minus 1 dx with a u. Our u is then going to equal whatever is inside of our composite, x minus 1. The derivative then has to be taken of the inside, so u then becomes the du, and in this case you're only left with a dx because the derivative of 1 is 0, and the derivative of x is dx. Now, we could substitute our u in for x minus 1, because x minus 1 and u, in this case, are now the same thing. Since we have a u, we no longer are with respect to x. So, that's why our du equals our dx here, because we are now in terms of du as opposed to dx. So, our du goes here instead of our dx, because they equal each other, thus they could just change. Now, please integrate this function.
Let's see.
Perfect. But this is not all the way correct. That's only because you still have a u here, but we were asking for the integral of x minus 1 squared. To fix this, we change our u back to x minus 1. Substitute back in, and you're left with x minus 1 cubed over 3 plus c. Understand?
Yes.
Okay. Let's do another. Let's make it slightly trickier. Now, in this case, we have a 2x plus 7. This no longer applies, and we need to use substitute. Because if we try to take the derivative of this, it would just be a big hot mess. So, what would our u now equal? Remember, the u is going to always equal the inside of the composite. What is the inside of the composite?
2x plus 7?
Good. Now, we have to take the derivative of u, so we get du. And what does that leave you with?
2dx.
Very good. But as you can see in this problem, we do not have a 2dx, we only have a dx. Now how we would take care of this is by taking the 2 out of here, and this now becomes 1/2 du equals dx. So now we have a dx, our u, and we're left with the integral of u to the 5th du. But we need our 1/2. We could bring that 1/2 right out in front. You get 1/2 times the integral of u to the 5th du. And once again, this is easily integrated into u to the 6th over 6 plus c times 1/2.
And then substitute back in, right?
Perfect. That's our next step. 1/2 times 2x plus 7 over 6 plus c will then leave you with 2x plus 7 over 12 plus c. It's as easy as that. Now, if we showed this problem to the calculus mugger, would you get your dogs back?
Yeah!
Wrong.
What?
After I substituted back in, did not put our exponents,
Ooh,
which is very key.
did not see that.
If you left those out, the entire problem is wrong. Thus, we check it over, and now we have our exponents, our u is subbed back in, our denominator is correct, and we did not forget our c.
I really hate when you do that.
Too cool. Let's give you your own example. How about the integral of 3x plus 6 raised to the 4th dx. Please you substitute this problem.
Let's see. U can be 3x plus 6.
Our u is always the inside of the composite, in this case 3x plus 6.
And then if you find the derivative of that, you get 3 dx. Gotta divide the 3. And then plug back in. Plug in for u. 3x plus 6. And plus c. How's that?
Let's ask fact checker Pav.
You are correct.
As you can see, Pav says this is correct. I don't see anything wrong with it myself. And we're ready to move on. Very good job. Now, we learned some key things yesterday with trig and integrating it. I'm going to give you a problem. It's going to incorporate that. Let's see if you remembered how to do it. How about the integral of x cosine of x squared dx? Where will we start on this problem?
Would u equals what inside cosine? So x squared?
Good, because cosine x squared is going to be our composite. We're going to take the inside of that and u sub that. So u is going to equal x squared. Now, we're going to take the derivative. In this case, du will equal 2x dx. But as you can see, we only have an x and a dx, not a 2x dx. That's very easy to take care of. As we saw before, we're just going to divide our 2's out. So you get 1/2 du equals x dx. Now we have our u for our composite, as well as our x dx and our x dx. This then becomes the integral of cosine of u du. And as I told you yesterday, we know this now.
It would be sine of u plus c, of course.
You know you like the angle I write on.
Now substitute in for u.
Very good. As easy as it gets.
You gotta stop doing that.
I get lazy. How about the problem x over x squared minus 1? What would your u in this case be?
I'm not sure. There's no inside the composite function.
So, take a guess.
I guess you could try the top x.
Okay. Now, if we substitute x, so our u is going to equal x, then our du will equal dx. Now, that does not help you at all, considering that we only have a dx, but then we're left with x squared minus 1 at the bottom, and we cannot just neglect that. So we're back to where we began, except we have a u. So we don't really want this. I'm going to erase this. I'm going to erase this. We're going to sub for the 2 term. Alright? So it becomes x squared minus 1 for our u. And now our du will equal 2 dx. 2x dx. Now, again, there's no 2x, but that's easy to take away by dividing by 2, and you get 1/2 du equals x dx. So you can see we have an x, our dx, and our u is now in the denominator. So we're left with 1 over u du. Because this was substituted for u, our x dx is covered by our du because du equals x dx, and we have the 1/2 out in front. 1 over u is very similar to what I taught you yesterday. Do you remember?
Of course. It's natural log of u.
Very good. Natural log of u plus c. What's our next step?
Substitute u back in.
Very good. Equals 1/2 natural log x squared minus 1 plus c. Got it?
Yes.
I think you're ready for this great battle with a calculus mover.
Oh no. My puppies.
I told you I'd be back Wednesday. Integrate these problems.
Oh. Well, luckily the mathematical messiah called me integration. Let's see. We could break these into separate integrals. Secant tangent, that is going to be secant x. E to the x is e to the x plus 7 times ln of x plus c. Let's go to the bottom. Ooh, it's gonna be require some u subbing. Let's split them up first. Let's see. U is equal to negative x. Du is equal to negative 1 dx. Bring the negative sign over. So it's going to be negative e to the u du. That's going to be negative e to the u plus c. And sub in for u, so negative e to the negative x plus c. Now for the other side, u is going to be x squared. Du is equal to 2x dx. There's an x here, but no 2, so divide 2 and move it to the other side. 1/2 du is equal to x dx. So plug back in. Integrate. Finally plug in for u. X squared plus c. Now finally combine the two. So negative e to the negative x minus 1/2 cosine x squared plus c. Done.
Let me see this. Impossible. There's no way you could have learned this in 2 days. It's almost as if you had some sort of divine influence.
If you only knew.
Well, I'm a man of my word. I was really looking forward to having those for dinner.
Yes.
Teacher, stop that screaming. Teacher, don't you see? Don't wanna be no uptown fool. Maybe I should go to hell, but I'm doing well. Teacher needs to see me after school. I think of all the education that I missed.
C? Where does that come from?
The C is a whole nother problem.
You know what? I think I've been covering a mic.
Oh.